So what's the secret to data-driven testing using Cypress? If you've ever copied and pasted the same test over and over and over again, just changing the data a little bit, you're gonna love this. In this video, I'll show you how to transform repetitive test cases into clean, powerful, data-driven tests. Stick around and see how you can add new test cases in seconds. And if you're serious about becoming a better tester, grab my free guide, Top 5 Test Automation Best Practices. The link's below the video. Let's get into this. Let's start at the top. What is data-driven testing and why would you use it? Let's take a look at some code that would be a perfect candidate for data-driven testing. To demonstrate data-driven testing, we're going to use a very simplistic login app. And this login is a fake login. It doesn't really do anything. I put in a few username passwords to say, hey, these are valid and anything else is invalid. So it's just all hard-coded in. There's no database or anything else. Just very simple ChatGPT generated form. So yeah, as you see here, if there's nothing, the sign in is disabled. If there's nothing in here, you a@b.com and put in an email address. You can see this turns green. Looks good. And then password, ABCD1234. Alphanumeric only password. So bad characters like star or pound would not let you sign in. And since this is not a valid user, you get an error. Okay, we have the valid users defined right here in the app. So user@example.com, password 123. User@example.com, password 123. Success. That's basically it. So we're going to generate test cases around this. There's a few other little things around here, like this has to be a valid email address. This has to be, password has to be like under 50 characters, alphanumeric only, and at least 8 characters. So if it's under 8 characters, so things like that, just so we have multiple variations of a cheesy sign-in form. So let's look at this without any data-driven testing. This is just, we're doing each test one by one. So this one's just going to be like 5 tests here. So we have a valid username password, and just basically what I just did in just logging in with a valid password. Here should show an error when you're using invalid credentials. And you look at this. So these are valid test cases, but they're all kind of repetitive, almost copy paste basically, and then you just change things. And it's basically all kind of the similar actions. You're putting in the username, password. You're seeing if you should be able to sign in or not, if that button is enabled or not. And then if you get error or success at the end, you're going to click that button and get error or success at the end. They're all doing this same pattern. When you have a whole bunch of tests like this, that's just different types of data, but you got these same types of patterns in the actual tests over and over and over again, you can greatly simplify using data-driven testing. And let me show you that in the next section. This is highly repetitive code that can easily become unwieldy as we add more and more tests. In the next section, we're going to show you how this code can be refactored using data-driven testing. If you want more pro tips like this, download my free PDF, Top 5 Test Automation Best Practices. The link is below in the description. The concept behind data-driven testing is really easy. You pull out the test cases into an array, and then you loop through those cases and dynamically generate the tests. You only need to create one test function that can handle every test case in the array. It's easier than you think. Let's see this in action. So now that we've seen this type of way of doing things. Let's look at how things look in a data-driven fashion, and I'll walk you through what it means. All right, I'm going to sit here and kind of just let you see kind of the high level here. I've just kind of collapsed everything just so you can see the high level overview of what data-driven testing is all about. So here's the test cases are defined in an array right here. And then the actual tests are generated one by one right here. So we have all the test cases, and we do a dot for each on this array up here, and then it generates all the test cases. So let's expand this and go into it more. So this is more than the 5 test cases on the previous thing. We've got, like, I don't even count how many test cases here, but we've got a whole bunch of test cases, like no username, password, empty fields, wrong stuff, and yeah, so whole bunch of test cases here, and you can see it's just an easily defined array. And you know what? It's like no effort whatsoever to add another thing here. So you can keep adding test cases over and over and over and over again as needed. Like imagine if we needed to test kanji or other Unicode characters, or we had to test, just whole bunch of different things. And maybe as the sign-in becomes more and more complex, as the devs like add more features, you can start adding in more test cases here. And it's easy. You just pop in one by one by one, and you can just keep adding more and more test cases to get full and complete coverage of this. And then to drop down here, here's the meat and potatoes of it. So if you haven't seen this before, it's very fun. You can dynamically generate all the test cases, and you can see this is just one it. So if I collapse that, you can see it's just one it right here. One test case. That's all it is, but it's wrapped inside this for each loop. So it's going to go through, and first things first, it's going to have this kind of pre-appended to everything. And then you're going to, add the index here from up here and the usernames. That way each test name is unique. And that's important. You have to have the names of the tests be unique. And not that I think Cypress would fail if the test cases weren't unique, but you need to be able to understand, like, hey, what does this look like when you're trying to debug it? And then you go down here, and this is where, we have some defensive coding here. Hey, we're going to fill in the form with the test data. So it's going to take that username, password, throw it in there. And then right here, if we look for what the results are, sorry, I forgot to say what types of results here we're going to expect. So this is kind of the little bit of a magic here. So there's 3 types of results. We're either going to have success, error, or disabled. So success is we successfully logged in. Error is we had the right formats of the username password, but the user didn't exist, so we get an error. And then finally, it's disabled because we have an incorrect format for the thing. Like this one is not 8 characters long right here, so it's disabled. Or the sign-in button's disabled. So those are the 3 states that we're looking for the results of this test. And this handles that. Says, hey, if I'm expecting disabled, then check if that thing is disabled or not. And it'll fail right here if it's not disabled. And also checks if there's no message at all. So yeah, if it's disabled, we shouldn't say success or error. And if the button is supposed to be enabled, then we click it right here. And then if it's supposed to be success, we check that success message. And if it's error, we check that error message. And that pretty much covers all the variations we saw on this other page where we had to keep doing everything over and over and over again, copy pasting down here. This one test case can be reused for all of these test cases. So this is like the template, and these are the actual test cases. So we're just feeding in data into it. And yeah, it's fairly simplistic form, but you can see, like, if you had something that's a little bit more complicated, this would save you so much coding time. You can just iterate through all these different test cases and just pop them out and add new ones easily. Let's see this in work. Let's see it in practice here. Okay, so this one is called data-driven. I didn't run the last one, the not data-driven. But this one's the data-driven one that we were just looking at. Let's click that up and just see it run here. And there you go. It's doing all those different test cases. I think I have one in here that kind of a bug because you can't, the form prevents you from adding a password that's too long. So, I just didn't fix that one. I left it in there. It shows you that, hey, there's something weird from your expected behaviors here if you thought you could put in more than a certain number of characters. But yeah, so this is why it's important to have unique names for each test. So that way you can kind of visually browse what each test case is doing. And you can just kind of look at the name of the test and see what's happening. Hey, these are the success cases, the error cases, and the disabled one test cases. Very important, the naming of the test need to be very clear for both you and the people who have to investigate test failures. But yeah, it's leaving this running. You can just add new test cases on the fly pretty easily. Just go down here and say, hey, let's see, I'm just going to make up something. Username. Let's put a bad, let's see, do we already have like a bad email example? Yeah, that's already a bad one, but we can do something else here. Maybe try to trip it up a little bit. Just go at something.com, at someone.com, at something.com. I don't even know if this is or is not a valid email address, to be honest. So password, valid password. Oh, I must have left ChatGPT on. Sorry about that. Results. We expect it to be disabled. This is not, I don't think this is a valid email. It could be. Rules for emails are a little bit strange, but we don't really even have that logic baked in. So I saved this. Let's go see what the test is doing. It's that last test. Oh, so here is the new test that we just ran. Whoops. Come on, collapse this guy. All right. And boom, there is the new one, and it passed. All right. That is an invalid email. Oh, yeah, because that one already checks for us. It already has some built-in stuff in the HTML framework to prevent bad emails. Cool. I didn't have to code that in. But yeah, it's very easy to add a new test case on the fly. And this is also better in another very, very fundamental way, is that if the behavior of that sign-in form changes, you only need to change one test case. You only need to change it here in this one template test case that gets generated. Versus this, you're going to have to go through each and every test case that you made. And this is only 5 test cases. Imagine having like 100 test cases for all the different variations of this sign-in form. And you have to go through and do that. It's going to take you a long freaking time to get through that. This is much more elegant to add them right here. But you see right here, we have everything added all in the same file. Let's see if there's some ways of like taking this test data, the data, and separate it from the actual implementation. We'll cover that in the next section. Now you've got one test structure that scales beautifully. Less code, fewer bugs, and easier updates down the road. But can we do more to separate the test data from the code? Now, what if your data starts getting too big, or you don't want it hard-coded in your test file? Let's see how we can solve this in Cypress. This separates concerns and makes your test file easier to scan. In the previous example, we had all the test cases defined within the test file itself. This may or may not be what you want. If there are a small number of test cases. I think this is fine. I think it's easier to maintain all just right here, and everyone can kind of just go to this one test file and add new things as you go. But if it starts becoming crazy long, like you have 1,000 test cases, this probably is not the best way of doing it. They're all in the same file. So instead, you probably want to take advantage of just separating out the data from the test. And that's what this next example is going to show. Let me click this next file, data-driven fixture with test. And so we see right here, we've removed that line, and now we are just importing the test cases from the fixtures directory, the Cypress fixtures directory right here. We got some fixtures, and we're taking in the login test cases. So we have our own JSON file, and we just defined all the test cases inside of here. Import that, and there you go. And it's the same thing as before, but just separated. So let's see how that works and see if it runs. There you go. And again, it's just as easy to add that stuff. And you can imagine too that we just have it defined in a file, but you could also even have all of this defined in a database. So you can just pull the code in from a database. That means you never have to even like change your code. You can just update a database and add new test cases directly from the database. I've never done that. I've never set up Cypress to do that, but it's possible. And I feel like if sometimes there are things where you can have thousands of types of data that you'd like to test. You probably want to use a database type of format, but that's beyond the scope of this video. Going back to the code though, you notice I'm using this way. Instead of using Cypress's sci.fixture, because when you put things into fixtures, Cypress has a special way of pulling in data from a fixtures directory. Unfortunately, I tried that and it does not work for this. There is a way that it works that I'll show in this single test thing, and I tried pulling in. All right, so right here you see that we have this thing that's outside of the test case, generating the test cases. And this is why it works, because the loop is processed first, and it generates the test cases, and then Cypress reads in the test cases. That's just the way the processing order of JavaScript and Cypress. That Cypress requires sci.fixture. It needs to be within a test case in order to work. If you do things outside of either a test case or this before hook, you can't reference sci.fixture or a lot of other sci.whatevers out there. It just doesn't work. That's not how Cypress is designed. You can't invoke Cypress outside of test hooks or the test cases, the individual actual test cases. So in order to use sci.fixture, you'd have to define it inside the actual test case. So let's go over here and let's show you how that's done. So you notice right here, it's not defined at the top with that require and importing it. So instead, we still have one test case. Let me collapse that. It's only one test case. And inside that test case, we do the sci.fixture, grab the data from that fixture. And then right here, we do that kind of for each pattern. And this will run all the tests. But this is not a good way of doing it at all, in my opinion. And let's show you why it's not a good way. So let's run this with the this pattern right here. And you can kind of see why it looks a little bit ugly. Let's run it. Okay, so it's running everything. It's doing all the tests that we did before. And once it gets to the finish here, you'll see the big difference. Okay, so that's done testing. The big difference here, look at this. You can't tell if something failed somewhere right here, you can't tell what test case what failed. It's really hard to parse out where you're at. What was the scenario? Like, you see, you have to look at the logs right here. It's like, okay, now we're doing this user example, and this should be a success, but you have to find these log messages, and they don't really stick out as clearly. It's kind of lost in all these other messages. And the worst part of this, though, is that if it hits an error, like it does here at the bottom, a test fails, it stops processing any further test cases. It won't go anymore. So you could actually have no more test cases in this one thing. It will stop doing the loop for any more of those test cases you find in the JSON file. So if there could be even a more serious bug that could run after this one, but you won't see it because it stops right here. It's one test case. As soon as the test case fails, it doesn't keep going. Cypress stops and exits the test case. So this is not a good pattern. I do not recommend it. I'm just showing you that you can use sci.fixture. With this pattern, I just don't recommend it. It is much more elegant to do the other way. But yeah, going back to this, just looking at just being able to go into a JSON file, don't have to mess with the code at all. You just add another entry into this JSON file, and you're good. You got the test case. I love that. I love data-driven testing. Whenever I see patterns and I'm writing test cases and I see these patterns emerging, like, oh, each form or each page that I'm testing does the same thing over and over and over and over again, I immediately go for data-driven testing. It is so much easier and cleaner and more legible. Plus, if your project manager hands you new test data, you just update the JSON, no touching the test code at all. But here's a quick question for you. What's the most repetitive test case you've had to write by hand? Do you think data-driven testing would have helped you at all? Or do you think this isn't worth it? Let me know in the comments. I'd love to hear from you. So now you've got the full toolkit for data-driven testing in Cypress. Stop duplicating test logic, separate your test data, and scale your tests like a freaking pro. And don't forget to grab your free copy of Top 5 Test Automation Best Practices. It's packed with shortcuts and real-world tips I wish I'd known years ago. The link is below. Now that you know the secret to data-driven testing using Cypress, you might be wondering how to use mock data in Cypress. How would you do that? It all starts by watching this next video, because when you pair what you just learned with what's in this video, it's way more powerful. All right, happy testing, everyone. Goodbye.